Hi, everybody. Welcome to Advanced Productivity for Data Science. I want to just really thank all of you for taking your lunch break here and joining this conversation. I will try and make sure we're at least as nutritious as the Greek salad. So with that said, there are the three of us who are going to be chatting with you today. Myself, my name is Karthik Ramachandran. I'm a group product manager. Jay, who is the director for the AI Factory and Gen AI at Mayo Clinic, and then Alex, who's also a product manager in Google Cloud, focused on Feature Store and a few other products. We have basically 4 goals for you today. One, we wanted to talk a little bit about the plethora of data science tools we have available on Google Cloud. Jay's going to give you a sense of how Mayo Clinic pulled some of that together to create a really nice experience for their users. We're going to share some opinions about architecture and how you may want to put these tools together in your own organization. And then finally, we're going to deep dive on 2 of our newer products, Collab Enterprise and Feature Store, that really help drive productivity across the data science lifecycle. So with that, I want to just start by saying, hey, what do we mean when we talk about data science? So data science is a super overloaded word. And for those who are practitioners, it can be somewhat of an overwhelming job. We really think about it as going all the way from a business problem to a deployed model. Now, that's not to say so much that every data science project ends with a deployed model. A lot of times, you kind of just get to a point where you need to do some data analysis, present some results. There are really kind of 4 major stages we think about data science as consisting of. There's a data engineering step, and for those who've been around the field a while, we know this is kind of where you spend the majority of your time. Data analysis, this is the fun part. You get to go in, see what the data actually shows. Then you actually get to build a model, and then you get to deploy that model and make sure it is actually part of a productionized workflow. Now, I want to say that one of the things is, given all the different steps here, all the different tasks you can see underneath each of these pillars, it doesn't mean that a single person is going to do all this work. We've really seen that data science has emerged into a team sport. It requires a lot of different tools across the various stages and tasks that you have to do. You want a lot of different people to be involved in the process. They're going to have different specializations, different knowledges, things like that. The good news is that Google Cloud really provides a tremendous breadth of capabilities in this area. On the data side, we have tools like BigQuery, Spark, Dataproc, Dataflow, Dataplex that really help you with analyzing, transforming, aggregating, and governing your data. And then on the AI/ML side, Vertex is kind of a one-stop platform that covers both generative and predictive AI use cases. So one of the things that we always talk a little bit about, or people always come up and ask is, does Google think about data science as being full-stack data scientists? No, we really do think about how we can provide different tools for the different disciplines within the data science field and the different types of tasks that you have to do. Which brings us kind of to the key challenges that end up being here. And I'm kind of curious as we go through this, how many people experience each one of these. So let's start with data silos. How many people feel like this is their biggest pain point or inhibitor to productivity? Oh, not that many people. I would have thought this would be like most of the room. So of course, historically, getting access to data has been the biggest challenge. We're going to be talking a little bit about some various lakehouse and data lake architectures, which make that much better, much simpler. Then the second thing is collaboration. We've already talked a little bit about how this is really a team sport. You're going to need multiple skill sets, people specialized in different tools as you go through the process. As part of that, you're going to want to think about how do the handoffs between these different teams and different specialists happen. As you get into that, you have artifacts now that are being managed and that need to be governed. You're going to want to see if you want to be able to keep track of their usage. If a model is being used, what data was it built on? Is that the right data set for that particular model and use case? If there's a problem that you later find with the data set, how can you go back and remove those models, remove those analysis from production, and rebuild them if you need to? And then finally, this brings us to productionization. Going from prototype to production can be a challenge. These tools are often different. You need different people with different skill sets. Sometimes you need to rebuild things. But also depends on what you mean by productionization, right? So productionization can be anything from an application with a model that serves millions of users to a notebook that you need to schedule and run periodically. So again, even in here, you're going to be looking at different sets of tools. So with that, what I would like to do is go ahead and introduce Jay, Director for AI Factory and Gen AI at Mayo. He's going to tell you a little bit about how Mayo has pulled together some tools to tackle these productivity challenges. Jay.
Thank you, Karthik. Hello, everyone. Very excited to be here and give you an overview of our approach in successfully setting up AI Factory on Google Cloud. Mayo Clinic is a nonprofit organization that is committed to clinical care, education, and research. We provide expert whole person care to everyone who needs healing. The primary value is the need of the patients come first. The mission inspiring hope and promoting health through integrated clinical practice, education, and research. Our vision is transforming medicine to connect and cure as the global authority in the care of serious or complex diseases. Mayo Clinic Cloud, MCC, is an ecosystem of data, AI, and cloud application hosting on the cloud. It is designed to achieve our Mayo Clinic vision of being able to self-serve and leverage the power of cloud-native technologies effectively. We have three key products, starting with Advanced Data Lake, which includes longitudinal patient record. This is where users view, analyze data in the cloud. And then we have AI Factory. This is where our users experiment, build, train, and deploy AI models. Users can access data from here, to the ADL, and as well as bring their own data or use public data set. Then we have Cloud App Factory. This is where our application teams build, test, and deploy applications. Users can access AI models that are deployed in AI Factory, as well as data in ADL. The Mayo Clinic Cloud is an opinionated implementation of Google product and services that align with our Mayo Clinic Cloud vision. Leveraging the MCC ecosystem will keep both AI users as well as product teams aligned with our Mayo Clinic Cloud vision, and as well as help in our journey as we continue our journey to evolve in this space. Mayo Clinic has various user personas covering different use cases and skill levels. Our users visualize and analyze data to derive medical insights. They build, deploy AI models that improve healthcare, lowers the healthcare cost, and reduce administrative burden. Our goal is to lower the barrier for users to start using AI and also provide advanced capabilities to our expert users to harness the power of AI. Let's take a look at AI Factory. AI Factory vision of simplified AI for all is achieved by providing a secure and safe cloud environment for Mayo Clinic users. The key objectives include providing seamless data access to our users, empowering our users through self-service and self-provisioning, delivering a full range of cloud-native tools that ease data exploration, development, and deployment of the model. It also helps drive innovation through early access to various features with our partnership with Google. Now let's take a look at some of the features within AI Factory. So AI Factory, we have established a service catalog that allows users to find and self-provision some of the commonly used features within AI Factory. The service catalog uses cloud-native tooling. It improves customer experience and time to market. One of the key features in self-service catalog is for users to access, request to access data in the advanced data lake. Now let's take a look at our data environment. The vision of advanced data lake is one query, endless data access through multiple touch points. The ADL and LPR, longitudinal patient record, contains multimodal data from numerous sources to be used in AI research, analytics, and application development. AI Factory lowers the barrier to the users to access this rich multimodal data with predefined connectivity and secure patterns. Now let's take a look at AI Factory architecture at a very high level. So this is a 30,000-foot view of AI Factory. So in the top center, you see we start out with Google Cloud, MCC, then we go into the Mayo Clinic Cloud MCC. Within Mayo Clinic Cloud, we have AI Factory, Advanced Data Lake, and Cloud App Factory. Within AI Factory, users are provisioned with customer project folder, which contains discovery projects and their model serving projects. Discovery projects is where our users access various AI Factory features like Vertex AI Workbench, shielded VMs, storage bucket, and various other features. It also provides pre-provisioned resources such as artifact registry and storage buckets that can be used right away. The self-service catalog is where most of the commonly used AI Factory features can be self-provisioned by the users. Now, looking at the AI Factory and generative AI ecosystem. AI Factory with embedded generative AI features provide a new platform to producing value and providing productivity gain. Gen AI features, LLM, along with other developer tools and domain-specific data, brings a new opportunity to advance AI in healthcare. Looking at how we are approaching our AI Factory work. We have taken a product development approach to establish and evolve AI Factory. The voice of the customer, strategic partnership with Google, and as well as the industry trends are some of the key features that influence our roadmap. The AI Factory teams work in an agile fashion, providing nimbleness with focus, relentless focus on collaboration, ease of use, and speed to market. We partner and collaborate to deliver on the value of vision of simplified AI for all within AI Factory. Let's wrap up with some of the final thoughts. Here are some of the outcomes and lessons learned over the past year with AI Factory 2.0. We started with AI Factory back in 2020 when the original AI Factory was established after the strategic relationship was signed. And the next major iteration of the product was the redefined AI Factory 2.0 that was released in April of 2023. Since then, we have provisioned over 150 AI Factory 2.0 projects with 500 plus users within first 10 months. We have enabled a lot of self-service, especially the generative AI features at a faster pace, lowered the barrier to the entry with simplified offering, starter kits, and a sandbox environment. The increased adoption and the end users able to provide business value by adopting the AI factory. Some of the lessons learned, the importance of partnering with Google all along. As the new features come in and lining up with our roadmap and collectively providing those features. The accounting for, we also ran into some of the challenges and we accounted for those, especially on the security side, like VPCSE controls, the timelines on those controls that we built into our roadmap GA timelines. And finally, one of the key things, underlying things, is the product development approach that we adopted that provide us with the nimbleness to rapidly roll out the features as they became available. And with that, I would like to thank for your time, and I'll hand it back to Karthik.
Thank you, Jay. That was great. So I wanted to just kind of take some of what Jay has said and kind of map it to some opinionated architectures that Google Cloud has published. Now, I think as you look at what Jay has presented, he's presented a very good converging architecture between data lakes and AI/ML architectures. So there's a couple of, on this slide, there's an additional reading. There's a nice paper there that you can go and you can kind of get some more details on this particular architecture. But I did want to take a few minutes to walk through the various layers of it and some of the tools that are utilized here. So kind of starting at the bottom with data ingestion, Google Cloud has a number of different tools for helping you ingest data from your transactional or internal systems into a data lake format here. And for that actual storage at the next level up, the data storage layer, we offer you a bunch of different options. You could choose something like Apache Parquet and place it on GCS. You could use the managed storage within BigQuery. And increasingly, we're trying to create a unified API layer on top of that that gives you access to the different formats and modalities of data that you have available. Moving up one more layer from there to the data consumption layer, both our advanced machine learning tools like Vertex, as well as our more traditional BI tools like Looker Studio, Looker, are increasingly able to natively read from these data stores that I just mentioned, BigQuery Managed Storage, GCS, our blob stores. We're also providing a number of different data processing engines, depending on the type of workload that you're dealing with. BigQuery provides a very high scale, very fast SQL-based execution engine. Dataproc gives you the power of Spark. We have Dataflow, which gives you beam and streaming capabilities. Moving over to the, I guess, my left, data governance. Dataplex is now becoming our single source of truth for artifacts across GCP for data and ML. And so you'll see, and Alex will talk a little bit about it, that we are increasingly integrated with Dataplex on the AI/ML side. So you'll see things like models and features now being stored there. You'll see the lineage that is now available to everybody. In terms of observability, the Cloud Logging and Monitoring Suite is really what's going to provide you that set of capabilities. So everything from being able to store and query logs to being able to see utilization metrics. We have a number of different orchestration tools for folks who are coming from the world of data. We have Cloud Composer and Dataform. We also have within Vertex pipelines for those who are looking for a more ML-driven tooling. And then in the Analytics Hub, there is a data sharing capability that's also interesting. So this is still, I think, a very complex picture. But I presented to kind of try and show how the different pieces fit together at different layers of functionality. If you're getting started, probably the best place to get started is with BigQuery and Vertex, right? BigQuery is very tightly integrated with Vertex. Your SQL-savvy users can access a wide range of ML capabilities through BigQML. You can use BQML to train models on Vertex or to run batch prediction. BQML also gives you access to our generative AI models now, including Gemini. If you have users who prefer maybe Python or doing something slightly more complex, those folks may want to go ahead and use data stored in BigQuery with the Vertex services. And increasingly, you'll find that Vertex services are able to consume that data fairly directly. Two examples of that we're going to be getting into next is going to be Colab and Feature Store, Collab Enterprise and Feature Store. So these two products are probably among our tightest integrations between BigQuery and Vertex, and they really make it very, very straightforward for you to access the data that you have, to be able to analyze and work with it, and they add a lot of productivity into your data science workflow. So with that, let me talk a little bit about Collab Enterprise. So I don't know, how many people are familiar with Colab or have used the public versions? Oh, great, great. So millions of users enjoy the public Colab, but the product was missing some of the key features that cloud customers and enterprises require. So at Cloud Next last year, we actually launched Collab Enterprise, which brings that Colab experience into GCP, adds a ton of the security and horizontal compliance controls that you need, things like regionalization, VPC-SE support we just launched. And the idea here is to give you an entry point within the Cloud Console where your data scientists can go in, very quickly start writing Python code, get access to BigQuery data, and you get all of those controls that GCP and Vertex are known for. True to the origins of Collab Enterprise, we've been trying to make sure you have a strong collaboration experience there, and that includes IAM-based notebook sharing, automatic version control, things like that. In terms of productivity and in terms of scalability, Collab Enterprise supports pretty much all the various compute types that are available within GCP. It's got integrated and streamlined data access to BigQuery, and we will be also supporting, or currently do support, code generation, code completion powered by Gemini. This is also now available in both the Vertex user interface as well as in the BigQuery user interface. So you can go through either user interface and get the same experience. Now, with that, I'm going to go ahead and hand it off to Alex Martin, our product manager for Feature Store. Thank you.
Thanks, Karthik. All right. By show of hands, how many here use feature stores today? All right. Looks like I got some work to do. How many know what a feature store is? OK. So we'll talk about feature stores. And for those who don't know what they are, I'll introduce you to them, tell you a little bit of a history of where they come from. And then we'll talk about the Vertex feature store, which is, I like to think, one of the best feature stores out there, but you get to decide. So feature stores are basically abstractions on top of your data infrastructure. So they help you manage less things while getting the same value out of them. They're centralized repositories of AI data and metadata, and they grew to actually include a lot more services than just storing and serving data. This is the diagram of a typical feature store. It happens to be the diagram of, you guessed it, Vertex AI feature store with BigQuery at the center. And to understand it, you have to go and look into how feature stores emerged as a product category. They emerged because ML data processing has some pretty unique needs. You have the training stage, where you process the data in batch, and you want to make sure that your interface is easy to use, and you can process lots amount of data efficiently, hopefully cheaply too, so that you can create those training data sets, iterate on those features, and get the training data in the shape that you need. But then when the model is ready and you deploy it for real-time predictions, your data needs change completely. It's no longer about batch processing. It's about processing each individual request as quickly as possible. And it's very quick. We're talking about sometimes single-digit milliseconds. And this millisecond latency has to maintain even if you have tens of thousands of requests, like some of our larger customers, like Shopify and Wayfair. Processing needs here are very different than what you typically do with a data warehouse. So usually, you would switch to a key value store. There are plenty of options out there. And to glue those things together, ML engineering teams create abstraction stacks. So they create something that basically helps you manage both the data warehouse side of your data processing and the key value side of your processing, because one of the core goals in ML is to avoid a train serving skew, which is what happens when whatever you've done during training is not properly replicated at serving, and so your model behaves differently, usually worse. So ML engineering team will build an abstraction. This is a very engineering way of solving this. An abstraction would guarantee that there is a proper data sync between your data warehouse and your key value store, that all the various forms of processing you've done during training can actually be replicated exactly at serving time. So that abstraction is a feature store. A few clever folks decided to make a product out of it, and that's how the product category emerged. Now, the train serving skew is just the core functionality of any feature store. In the years that they've been around, they've evolved to provide you a lot more, namely things like data discovery or feature discovery, feature monitoring, and new feature engineering. And I'll talk a little bit about that. So what makes Vertex Feature Store unique? There's three things. Number one is that we're very deeply integrated with GCP, specifically BigQuery. Sometimes we even call our feature store BigQuery Feature Store. And we use BigQuery APIs directly. This is very different than many other feature stores that actually copy your data, and so you have to pay for additional storage, and it's often just very inefficient. We use BigQuery APIs directly with all the flexibility and all the power that they provide. Next is real-time serving. We have two options. They're both very low latency. Number one is based on Bigtable, which is one of the leading key value stores out there. It performs extremely well, no matter your read or write workloads, and it offers a pretty good latency and lots of other innovative features. Many of you may have attended some other sections covering Bigtable at this conference. We also have another serving option. We called it Optimized Serving. This is a custom database that's built by Feature Store team specifically for the needs of machine learning serving. This is often much more cost efficient to use that than an in-memory database, despite meeting the same latency criteria of in-memory databases, often in single-digit or low single-digit latencies. The last thing about our feature store is very unique. So we actually have a built-in vector database. That means that you no longer have to manage a separate database because you're covered between the BigQuery's vector search and the feature store's real-time vector serving. The reason we did this is the same reason why we've included all other options for data serving, because vector databases represent a separate infrastructure that you have to manage. You have to manage the syncs to, you have to manage the states, and so forth. We give you a built-in option that's actually using the same algorithm that is used in many of the Google services like YouTube and Vertex's own Vertex AI vector search. It offers very high performance. The library is called Scan, for those of you into this. It offers very, very good performance regardless of the workload. So 10,000 QPS is no problem for us. We're still going to maintain that latency. It works really well to pair BigQuery and Feature Store, because BigQuery gives you this serverless vector processing. That means you can iterate really fast and really cheaply during your kind of pre-production stage. You don't have to maintain or keep up a 24/7 database just to do two or three queries as you experiment. But then when it comes to real-time serving for your end users, you can quickly use Feature Store with an automatic data sync. And most importantly, there's also a performance benefit, because we co-host our vectors with the metadata. And in most actually of the vector database workflows, what happens is you get similar vectors, then you get metadata, then you filter it, and then you get the document that this vector represents. Those often are hosted in completely different systems, and if you want to do the full end-to-end query, it ends up being, even if your vector search is really fast, your full query may be pretty slow. With Feature Store, all of this is hosted in one cluster. That means that your whole latency is much lower. And the management of the system is much easier as well, because it's just one API that you have to enable. So I can talk more about generative AI, but there's maybe 100 other sections that can cover this. So we'll move on into predictive AI and some new features that Feature Store announced just a few months ago. Number one is Dataplex integration. As Karthik said, Dataplex is becoming the centralized metadata store for all of Google Cloud. It used to include just the data artifacts. Now it includes modeling artifacts and many others. And it also offers really powerful APIs to search and navigate these artifacts. We now have an integration with Dataplex as well. So Feature Store metadata is available as one of the artifacts in Dataplex. Then there is Streaming Sync, probably the most requested feature that we had since we released Feature Store in general availability in November. And this is to allow you to have very, very good data freshness. What that is once your data appears in BigQuery, it would appear in your online store within seconds. So it's very useful for use cases like fraud detection, where you want to make sure that the latest data is used to power your fraud models, and product recommendations as well. The other feature is composite key lookup. Again, this is super useful for product recommendation use cases. Typically, what you want to do is you have some basket of recommendation, which contains multiple products, and you want to retrieve metadata for each of those products. In traditional architecture, you would actually run sequential calls for every product, every metadata item of that product, and that can take quite a while. With composite key lookup, you can put all of those into one request, get your data faster, and again, reduce your overall latency for product metadata retrieval. And then we have two experimental features, which we've developed together with our Google Cloud research teams. And these are both aimed at new feature engineering. Many of you here probably experience this personally. There is also a lot of surveys to confirm that feature engineering continues to be the most time-consuming process for any data scientist as they go through an end-to-end model development. And it's also a very manual process. Typically, the way you decide on which features to use is you try a few things, then you try a few more things, and hopefully, eventually, you'll get to something that's useful, or you'll just use a template from before. We gave you two tools. We're introducing two tools for Feature Store. One is called Feature Search. So that allows you to scan your feature store. If you've put all your features in there, what we can do is use a proxy algorithm to kind of quickly evaluate if any of those features may be useful for a new model. And then the other one is where we scan not just the features themselves, but also the transformations that may convert those features into a useful feature. This is very new, and I'll talk about it in just a few minutes. So first off, the Dataplex integration. As we said, I think 3 times now, Dataplex is the centralized place for all of the metadata in GCP. Feature Store metadata is available there now. A few months ago, we actually started to push the Vertex model metadata in Dataplex as well. And Dataplex as a product gives you really, really powerful tools to query that metadata. It's kind of like a giant graph of various assets that you have. And you can construct the fairly flexible and advanced queries to extract the data and build things like workflows, like IAM policies for governance. Or maybe you can look at things like, for a particular feature, what are the models that are performing really well or poorly, and then maybe give a rank of the features that are helping your organization the most, and then estimate the cost of maintaining those features to arrive at some kind of feature ROI. This is only possible if all of your metadata is combined in a single storage. Dataplex is that storage, and it gives you many powerful tools to work with it, extract information from it, discover and monitor your features, your models, and your data assets. We're really excited to integrate and spare you from doing this integration yourself. This is one of the advantages of using Feature Store, is you get a lot of built-in things. Next, let's talk about feature search and selection. There's a whole body of research talking about using proxy models to evaluate if your data is useful for a particular model. Probably everybody used correlation at some point as a very crude proxy whether a particular data can be useful for a model. Now, feature search is kind of like correlation, just much, much better. Correlation typically gives you very noisy results, like here's a bunch of features that are useful, but they all correlated with each other, so you can't really tell if any of them would be useful when used in unison. So a lot of these feature search algorithms are actually can look into what's called mutual information and see if a feature is useful while not being correlated with other features. That allows you to compose sets of features that can be useful for your model without being crowded by many of them. And you can do the reverse of this. When you have a model with way too many features, you can actually run a feature search to see if you can remove some features, make it a smaller model that's going to perform a lot better and at least respond faster. And the best part about it is that the algorithms we exposed are developed with Google research. That means that they're extremely scalable, they're extremely fast, they can work on very large feature spaces. If you have 1,000 features, 10,000, even 100,000 features, we can still scan them pretty well. So we encourage you to build workflows where for every new feature added, you'll actually be evaluating if it can be useful for some of the models already in your catalog. And if you get excited on the previous slide, this is way better. So you can not just evaluate the feature itself, but you can see here on the graph, I got some formulas. So these are actually transformations that we can investigate and tell you if they can be useful for your model. So it's not just the feature itself, but some form of transform applied on it. And these are very easy to read. So we have a specific algorithm that not only finds the transformation, but tries to find the type of transformation that is humanly interpretable. And then you can take this transform and maybe plug it into your LLM to get some business intuition for it and potentially explain it to your users. This is very new. And the feature is experimental. I probably should have said it multiple times. So we encourage you to reach out to our teams and get on the allow list to see access for it. But we've seen very promising results, and there's a research paper that's about to be published on it. For new feature engineering, I want to leave you with sort of a vision for how we hope feature stores can change the workflows of your teams. Imagine if every time a new feature is submitted to the feature store, there is some CI/CD process or some kind of process that looks whether this feature can be useful for any of the models currently deployed in production. And when it finds the model where this feature can be useful itself or with some form of transformation, it sends an email to the model owner saying, hey, there is a new feature published which may improve your model. You should check it out. Today, this is almost impossible because nobody knows where your data resides, who owns it, how it works. With Feature Store, if all of your teams are on it, you can have automated workflows that make it like a marketplace of features. Much like you often get those e-commerce emails saying that here's some new products that might be interesting for you, your machine learning teams can be getting those emails saying that, hey, here's a new feature that's been published by a team that may not even be related to your team that may be useful for your model. And that encourages the dialogue, encourages collaboration, and improves your models. So, wrapping up, we had quite a session talking to you through various advances in data science and productivity for data scientists. We went through a number of architectures to show you various tools in Google Cloud that can be useful for your data scientists, can improve their productivity, can help them collaborate and build models effectively. We gave you a real-world example with Mayo on how to build an end-to-end system on GCP and how to make your employees and your data scientists really powerful with that system. And I think that when it comes to productivity, especially with data scientists, like one of the main things that I encourage you to try and do is make them self-sufficient. Allow them to go end-to-end from data exploration to data management to even serving, and build tools for them that are easy to use, but most importantly are integrated with each other so that they don't have to learn those tools and they can focus on data science while getting all the benefits of the tool set that is state-of-the-art in whatever capability it provides. So we showed examples of how BigQuery can be at the center of your data journey. It can be the main data set or data provider to power Vertex, to power your data analytics and exploration, and help you build powerful models with Vertex AI. It works great with Colab to quickly explore data, to experiment on models, maybe even build some models. And it's very deeply integrated with Dataplex to keep your data organized, protected, and very explorable and debuggable for whatever problems you can incur in production. Lastly, I showed you how Feature Store bridges the gap between training and serving while improving your data scientist feature engineering productivity. We worked really hard to make sure that all these products work well together so that you don't have to do that. You don't have to worry about your infrastructure. It can focus on what matters the most for your business. Thank you.